Hi and Assalamualaikum. My name is Sharifah Nur Azanim binti Said Nur Azalan, and today I would like to present about ocean ion fertilization or OIF. But what does this phrase mean? So, OIF means the addition of iron, which is a nutrient, into the ocean in order to increase the productivity of phytoplankton. This is equivalent to when we choose to put fertilizers on land plant in order to boost their growth. But why do we have to do this? So when we do OIF, this can stimulate carbon sequestration, which transport the atmospheric carbon into the deep sea by biological pump, and this will then lower the atmospheric carbon dioxide level, which then lower the global temperature and acts as climate change mitigation. But does climate change is even real? In order to study climate change, we need to have data. But what kind of data? A minimum of 3 decades of or 30 years old data need to be used in order to study the change in climate. So in 1983, scientists had found trapped air bubbles in the Arctic Antarctic ice cores that contain atmospheric carbon information of last glacial maximum, which is about 20,000 years ago. The pictures show how scientists get the ice core. So back then, the data were analyzed and then compared with the pre-industrial era. Scientists found out that the carbon concentration during the last glacial maximum is actually lower compared to the pre-industrial era. This finding confirmed that climate change is really happening. So since then, scientists had tried to find ways in order to mitigate climate change, and one of it is to reduce the carbon dioxide concentration in the atmosphere condition. This lead to the next topic, which is the Martin's hypothesis. So, what is Martin's hypothesis? John Martin, which is a biologist, proposed a hypothesis which is adding iron into the ocean would cause dramatic multiplication of phytoplankton, which could lower the global temperature. Actually, this hypothesis is actually sparked by Joseph Hart, an English biologist, during 1934. But then, only on 1983 did scientists found evidence of climate change that really happens. And since then, Martin had found interest in this topic. Then, on 1988, Martin finds that primary productivity in high nutrient, low chlorophyll regions was actually limited by the presence of iron. Then, in 1990, he found out that during the last glacial maximum, the dust inputs were high. Dust inputs that contains iron may become the boost of phytoplankton growth, which then lead to the last glacial maximum era. The Martin's hypothesis then become the base of the ocean fertilization experiments, which have the objective is to stimulate oceanic carbon sequestration through biological pump in high nutrient, low chlorophyll (HNLC) regions by adding iron as fertilizing agent in order to induce phytoplankton bloom. So, what really is the iron climate relationship? As you can see in the slide, during the cold period, which is when the carbon dioxide concentration is at the lowest, there had been iron flux in the Antarctic region, which may indicate that when iron concentration is high, carbon dioxide concentration is low, which then lead to the change in climate. Next, this slide shows two different conditions, which is the left one is without iron and the right one is when iron is added into the ocean environment. So, when we compare these two conditions, we can see that even when there are the same amount of light intensity, phytoplankton abundance is higher when iron is added compared to without iron. So, when phytoplankton abundance increase, this will increase the carbon dioxide intake by the phytoplankton in order to do photosynthesis. When phytoplankton die, they will become organic matter and settle into the ocean sediment. So when there is higher phytoplankton bloom or higher phytoplankton abundance, there will be more organic matter that will be deposited. From this diagram, we can conclude that when iron is added, there will be more carbon dioxide sequestered. This will lower the atmospheric level of carbon dioxide, which then lower the global temperature and help in reducing climate change effect. Back with our ocean fertilization experiment. So this experiment is conducted at 4 different areas, which is subtropical North Atlantic, equatorial Pacific, subarctic North Pacific, and Southern Ocean. Why are these 4 areas are chosen by the scientists? It is because these areas have high nutrient, low chlorophyll HNLC region, but contradictorily, they have low primary productivity level despite having high nutrient availability. Other than that, some of the area have high light intensity and temperature, which promotes phytoplankton growth, as these are the suitable or optimal condition for them to grow. Ocean ion fertilization experiment can be separated or categorized into different types, which is natural ocean ion fertilization (NOIF) and artificial ocean ion fertilization (AOIF). So overall, there have been 19 experiments conducted. 6 of them is natural, while 13 of them is artificial. So, out of all artificial ocean ion fertilization, can we consider them as a success? In my opinion, after reading the article, artificial ocean ion fertilization is not a success. It is because overall, this experiment did not achieve its objective. According to the results gained from the AOIF, yes, the phytoplankton community did respond to the addition of iron positively, like the taxonomic shift towards diatom communities in iron X2 and diatom blooms in Soiree and Asen X. But one particular experiment showed no response at all from the phytoplankton community, which is the experiment SAGE. Next, out of 13 experiments, only 3 showed significant results on the transport of nutrient to the deeper layer, which indicates the carbon sequestration, which means the other 10 did not show proof of carbon sequestration had happened. So, only 23% of ocean ion fertilization experiment conducted that achieved its objective. Next, there are 4 limitations occurred that may be the potential cause of the unsuccessful experiment. First is insufficient experimental duration. Second, high grazing pressure. Next, limitations of micro and macronutrients, and light limitation occur due to storms that happen in one of the experiments. Thus, future improvements needs to be done in order to improve the results of ocean ion fertilization. In this slide, I mentioned 6 different improvements that we can do in order to improve the results. Firstly is the location. Choose a suitable and optimal location that will improve and maximize the results. For example, we can choose to perform OIF in the eddy structure as they have low grazing pressure and high level of silicates, which indicates high abundance of diatom. Next, in order for us to gain more accurate data of carbon flux that happen during the OIF, we should employ MBST system and water column derived 234TH method at 2 depth, along with autonomous profiler that have UVP and transmissometer. Then, we need to increase the duration of observation with a minimum of 40 days to prevent potential insufficient experimental duration. In order to trace iron fertilized batch, we need to use both physical and biogeochemical traces. Along with the experiment, we need to also monitor the side effect of putting iron into the ecosystem by using optical sensor equipped with autonomous mode profilers or benthic vehicles. Lastly, we need to perform the OIF experiment at the strategic timing, which is when the optimal phytoplankton bloom. For example, at the Southern Ocean, we can choose to do the experiment at the early of the summer. So, that's all from me. These are my reference, and thank you for listening.